So, in order to solve the rational equation, first we're going to clear the fraction. So, we're going to find the least common denominator of all the denominators. In this case, that's only x for this first example. So, what we're going to do with that, though, is a little bit different. We're going to multiply every term of the equation by this least common denominator. So, we'll multiply the 2. We'll multiply 6 over x, and on the other side, we'll multiply to the x and to the 7. We'll multiply every term by this LCD. So what's going to happen, for the first term, that's 2x. For the second term, that's going to divide and cancel out the denominator. That's why we did this. So that leaves just 6. On the other side, x times x is x squared, and 7 times x is 7x. So now we've cleared out the fraction in the equation, and we're left with this equation, which the highest degree 2 says this is a quadratic equation. So that means I want to solve this like in chapter 6, which means I want 0 on one side. So I'm going to choose this side since the x squared is on the other side. So I'm going to subtract 2x from both sides and subtract 6 from both sides. That way we have 0 on the left side of the equation, and on the right side, x squared plus 5x minus 6. And then I want to completely factor this side of the equation. It's a trinomial, so let's see if we can get factors for the first and last term here. And they're going to be different signs, so I want to use 6 and 1. The bigger number is positive, so that's going to work there. We have factors of x plus 6 and x minus 1. Awesome. Then we just need to set each factor equal to 0 by the zero product property, as long as it contains a variable, because what would we solve for if it wasn't? So it's going to opposite those number terms, giving us a negative 6 and a positive 1. But here's the thing with rational equations. You must check. What are you checking for? You're checking to see if these solutions will be true and do not cause any part of the equation to be undefined. Because if they do, they're not actually solutions. So, let's go ahead and check these. If we were to use a negative 6, so 6 divided by negative 6 and negative 6 plus 7. So that's going to be a negative 1, and that's going to be a positive 1, and 2 minus 1 equals 1. That's right. So the 6 is good. Let's check the 1. So 2 plus 6 equals 1 plus 7. That is also true. So that tells us these are both proper solutions to this equation. They do check out, and they don't make any part of the equation undefined. So be careful with rational equations that way. Now, our next example, we need to find the least common denominator. And so that means we need to make sure everything's completely factored first, which this is not. So we need factors of x squared and factors of 15. That might add up to a positive 2. Bigger number is positive. So those will be the factors for that denominator. So now the least common denominator, I need an x plus 5, and I need an x minus 3. And that's no longer unique, so those factors are all taken care of. So this is what I'm going to be multiplying each of the terms here, and I'm going to keep their denominators factored when I do this. So multiply the LCD to the first term of the equation, and the second term, and x plus 5 and x minus 3. That's the least common denominator. And on the other side, I'm going to also multiply the LCD here an x plus 5, and an x minus 3. And we always multiply to numerators, of course, because they will cancel with denominators. So let's cancel out all the denominators that we have. X plus 5, x minus 3. And so for the first term, that's going to leave us just the 7x here. Now the second term, we're going to cancel out the x minus 3. And that's going to leave 4 and x plus 5. Then we want to go to the other side. We can cancel out an x plus 5 factor, and that leaves negative 2 times x minus 3. So let's see what we have left here. We need to do some distribution to remove parentheses. So 7x minus 4x minus 20 equals negative 2x plus 6. And then if we've got some like terms, we definitely want to combine those. So 7x minus 4x is 3x altogether. And then I can tell that this is a linear equation because the highest exponent is 1. So I'm going to use the steps for solving the linear equation. I'm going to opposite the variable term here so that my variable terms will both be on the left side here. Sorry. So that's going to be 5x's altogether on the left and just 6 on the right. And then I want my number terms to be on the other side, so I'm going to opposite that term there. So I have just 5x on the left and 26 on the right. And then the multiplication property, I'm just going to divide 5 from both sides to get x by itself. So I think that x should be 26/5. And if I go back to the original equation, and yeah, I'm not going to do that, but it doesn't make any of these denominators 0, and so it's definitely not going to make any part undefined. I just need to make sure that this is true, and then I can confidently say that that is the solution to this equation here. So another examples, we've got equations here. So our first step is to find the least common denominator. If I look at the denominators here, I just need an x minus 1 at most once. So let me take that and multiply it to each of these terms. So multiply to the first term on the left side and the first term on the right side. And also multiply to that second term on the right side. So now we can do some dividing out of denominators. So cancel those out. That makes the first term, I'm going to move over this way, 5x on the left side. Let's go to the right side, cancel out the x minus 1. So that leaves just 5 for the first term on the right side. And then we got some distribution here. There's no canceling, right? Because there's no denominator. So we're just going to distribute 3 times x and 3 times negative 1. Then we do have some like terms on the right side. So I'm going to add those together first. 3 take away from 5 is positive 2. And then I noticed that this is linear, right? The exponent's only 1. So we can opposite the x term here from both sides. Then we'll have 2 x's on the left and just 2 on the right. And if you solve this by factoring, you should get the same answer. So it doesn't make any difference. We're going to use the multiplication property so that x is just 1. So we think that x equals 1 is the solution to this equation. Let's go back to the equation, and if we were to check that, so let's check 5 times 1 for x over 1 minus 1 equals 5 over 1 minus 1 plus 3. And here's the problem. 1 minus 1 is 0. You're going to be dividing by 0, and that is not good. So do you know what that means? That means 1 cannot be a solution to this equation. It does not make this a true statement. It makes these parts undefined. So that means that this is not a solution. And since that was the only solution that we found, what are we going to say is the solution to this equation? We're going to say there is none. There is no solution to this equation. Because even though we found one algebraically, it does not work. So this equation has no solution. Then our next example here, we've got a rational equation, so we need to find the least common denominator. And there's only denominators of x plus 3, so we need at most one of those in any of these denominators. So let's go ahead and multiply each of these terms by this least common denominator. So on the left side, we've got 2 terms here getting multiplied. And on the right side, we've got the first term times the LCD plus the second term times the LCD. Okay. So for the first term on the left side, there's nothing to cancel with any denominators, so we're just going to distribute x times x is x squared, and x times 3 is 3x. For the second term, though, we do have some denominator to cancel out, and that's going to leave just minus 6. On the right side, we do have a denominator on that first term to cancel out, so that's going to leave just 2x. And that second term does not have any denominators to cancel out, so we're just going to distribute 2 times x is 2x, and 2 times 3 is 6. Left side, no like terms. Right side, we do have like terms, so we're going to add those together. 2x plus 2x is 4x. Okay. And I noticed that the highest exponent is 2 here. So that means I want 0 on one side. I'm going to choose to opposite the terms on the right side. So minus 4x minus 6 from both sides. Then we will have 0 on the right. On the left, we'll have x squared. And 3 minus 4 is minus 1x. And negative 6 minus 6 is minus 12. Awesome. We've got 0 on one side. Now we just need to factor the other side. And this is a trinomial, so that means we're going to look for factors of x squared and minus 12. That adds up to minus 1x. So maybe 4 times 3, those are different by 1. And the different signs, the bigger number is negative, so that works. We'll have an x minus 4 and an x plus 3 as our factors here. So then if we set each of those factors equal to 0 by the zero product property, we're going to opposite those terms. So we'll end up with a positive 4 and a negative 3 for our solutions. So we think those are our solutions, right? But we've got to check them. So mainly what I'm looking for is if either of these causes the denominator to be 0. So if I check 4, that's going to be fine. 4 plus 3 is 7. So the denominators are not going to. But if I choose the negative 3, then my denominators here are going to be 0, which is undefined. So that's no good. So what that tells me is negative 3 is not a solution. But 4 is fine. So there's only one solution here, and that is that x equals 4.